Okay, good afternoon, everybody. I'm Tim Moreton. I'm the founder and CTO of Acunu. I'm going to talk this afternoon to you about real-world, real-time data modeling. So I know it's the last session of the day, and I'm only a small way between you and Cassandra branded ale. So I'll try and keep it to the point. But what I'm going to talk about, I guess I'm going to give you the story of a couple of customers that we worked with who are building real-time analytical applications on Cassandra and some of the data modeling techniques that they used and that we helped them to build their application. And I think they're pretty generally applicable and will be valuable to you guys as well. So to start with, who the hell are Acunu? Well, we love Cassandra. We've been using Cassandra for a long time, since 2010. In fact, we've been working on and using Cassandra and helping customers with it. We contributed a lot of the design and implementation work around virtual nodes. We originally actually built that for one of the customers that we were working with in the UK, Telefonica O2, one of the UK's largest mobile providers. They use Cassandra and Acunu together to collect between 300 and a billion a day at peak event detail records, which are routing messages from SMS messages. But they had a large amount of data on each of their machines, and they had a particular problem with that. And that sort of approach where we work with customers and end up building product on the back of that is exactly the same story I'll talk about for the rest of this presentation, but mostly focused on data modeling. We also did a lot of work on the Cassandra query language and earlier incarnations, and it's great to see how far CQL3 has come. We also provide support to some of the world's largest enterprises and smallest startups around Cassandra and services around it. But as I say, this talk is really looking at the experiences that a few of the customers that we engaged with on a support arrangement had, and the lessons that we learned through that from a data modeling perspective. So how do you build applications on top of Cassandra, and how do you get to grips, coming from a relational world, with the fact that CQL and the Cassandra engine are just a fundamentally different beast. So before I dive into that, I think it's worth sort of pulling up a bit of experience that we have about how people are using Cassandra, just to sort of set the context here. So on the one hand, one broad category of use case that we see is around session storage. So that's where you perhaps have user profile information. Perhaps you're in a social gaming organization and you're keeping the state associated with each user. And maybe you have 50 million of these. You push the state into Cassandra, you pull it out, you look at it, maybe you do an update on it, and you push it back. That's a common use case. That's a common use case that we see. Certainly not unique to Cassandra, but it's certainly a major aspect of usage there. And then the other side, I think, is real-time analytics. So this is certainly a different beast in terms of the workload and the fit of Cassandra to this problem space. So here you're dealing with a stream of events being collected by Cassandra, and you're looking to summarize or aggregate or in some way pull information out of Cassandra, which is a reflection of the data being put in, but isn't the data. You very rarely do updates in this situation. So the characteristics of these two data sets are pretty different, and I think it's worth looking a little bit about at that in terms of if you're looking to build an application on Cassandra, if you're perhaps looking at various NoSQL or NewSQL technologies, and you're thinking about, is Cassandra the right fit for me? It's good to look at these characteristics and sort of put your problem space into that, fit your problem into this space. So with session storage, quite often your workload is going to be very read heavy. You often want atomicity, or you want some reasonably strong guarantees about what is going to be happening to the updates that you're pushing into Cassandra, or the situation in which you're making those updates. So also, if you look at it, even if you have 50 million users, if you have a kilobyte of data for each of those users, you're still only talking less than the memory capacity of a single modern machine. So, big data is a word that gets thrown around quite loosely, but I would describe many of these session storage use cases as probably not big data. With real-time analytics, it's often quite different. We've seen workloads where people are collecting clickstream data, telemetry data from telcos, infrastructure data, log messages, and financial market data, and a range of other streams of data, typically coming at you with high velocity. And there, the balance of reads to writes is often very, very different. We typically see 100 times more writes than reads. And all the reads are to the summaries or the results or the analytics that you're getting out the other side. You rarely want to read the original events that have actually gone in. And this, for any real system, this really isn't going to fit in RAM. So it's worth looking at, Jonathan set out this morning actually a very, very similar list of Cassandra's strong points, and I absolutely agree. You've got scalability, high performance, especially write performance, high availability, so taking advantage of the fact that a cluster can span multiple data centers or racks and be aware of that topology and work around it well. Those three facets are really strong points of Cassandra, and one of the challenges that still remain is it's certainly common to many distributed systems, is being able to get strong transactional semantics. So, for session storage, if you look at it, the scalability is not so much of an issue. The write performance is not particularly helpful for this workload. Often high availability can be useful, but you're still stuck with some of the ACID semantics. It's worth noting that the compare and swap operations coming in Cassandra 2 will greatly ameliorate this. That's for sure. On the real-time analytics side, however, the picture's quite different. So scalability is really important here. You're typically going to be collecting large volumes of data. I gave you one example with Telefonica, but earlier this week I was working on a customer where they were collecting 1.5 billion events a day, and they want to keep these. They want to keep these, and that's far from the highest that we see. The imbalance in the reads to writes means that write performance is a really useful characteristic of Cassandra, and high availability here is still useful. But you don't need strong transactional semantics in this workload, and I'll come on to show you why. So, one of the I guess it's slightly contentious, but maybe what I'm saying here is that there are many systems for which you can go to for session storage. Lots of users use Mongo, lots of users use a number of different solutions here. If you want high availability, Cassandra is pretty much the only solution out there. But for real-time analytics, it is a very, very good fit. And building applications that need to get insight out of high-velocity streams of events is a really common and natural use case for Cassandra, and I suspect that many of you guys in this room actually have that problem. So that's, I guess, the sort of the rest of the talk is going to focus on data modeling around real-time analytics applications, but these trends are probably going to be useful as well if you do have a session storage application. In particular, though, I'm going to focus on one example use case, which is not O2 Telefonica, but it is another telco. It's where we were asked to sort of help with a system where users were collecting tens of thousands of call detail records a second, and they wanted to do network monitoring. There's several different use cases here, looking at drop rates, being able to track outages as they emerged, and understanding how and which customers were involved in and implicated in these problems. So what we're really talking about here is operational analytics, right? So it's not needle in a haystack type processing where you're collecting different data sets together and hoping to come up with some insight which is going to transform your business in an abstract way. It's very to the fact, to the point. You use your domain knowledge to understand, to apply the metrics that are important to your business, and then you want to be able to know what is happening to those metrics within a small time period. There are many use cases for which this applies. If you are if you're doing advertising analytics, it doesn't take a Hadoop cluster to tell you that click-through rate is a metric that you should be tracking. Likewise, latency on API requests. So these guys were looking to turn call detail records into real-time dashboards so that they could take corrective action when issues arose and just check that changes they were making to the setup were working fine. And they were using Cassandra to do this. So I'm going to talk about how they did that. So to start with, I'm going to just quickly summarize some basics from Cassandra data modeling. This may have been covered at a couple of other talks today, but I think it's well worth driving it home. The first thing is that you need to denormalize. Cassandra is not Oracle. It's not a relational database. You need to insert data in every arrangement in which you wish to read it back. That gives you a lot of power, but with great power comes responsibility. And it's also a bit of a challenge, as we'll see later, to maintain agility when this is the case. The reason you can do this is because Cassandra has a great storage layout, which means that random writes, or writes to random keys, more correctly, do not necessarily or are unlikely to incur disk seeks. So that means that, whereas in relational databases you tended to end up getting performance constrained on writes, that is unlikely to end up being the case anymore, unless you have some pretty interesting data sets, in which case, come and tell me about them. The second thing is that Cassandra's data model has a couple of important facts you need to know about it. So rows are used to organize data around the cluster. If items are going to be accessed together, you want to put them in the same row. And in particular, rows allow you to efficiently maintain sorted data. So column keys end up getting sorted. So the row is your partition key in CQL3 terms. The converse is also true, right? So sets of items that you're likely to not access together, you should not put in the same row. And there's no point incurring the cost of having to maintain those being sorted. And in particular, you're probably going to end up with enough stuff in each row that you need to somehow distribute your load across your cluster. And the final sort of basic tenet here really is that atomic counters are a really useful building block for building real-time applications. So Cassandra can allow you to insert what are essentially plus ones into the system, and when you read them back, you get the actual value. And this is a great building block for not all real-time analytic use cases, but pretty much most. So just to highlight this, one event update is likely to result in potentially many updates across rows. Don't worry about that. It's absolutely fine. That's to be expected. One query read typically will hit one row, or should hit one or a small number of rows, and you're doing well if you can make it touch sequential columns. That's your sort of perfect setup for a Cassandra data model. So what follows, I guess, is a cookbook of several techniques that we help this customer adopt. And that's only the first part of the story. I'll tell you what happens afterwards. So the first thing they wanted to do is be able to track the occurrences of certain metrics and be able to do so by a variety of different time hierarchies. So they wanted to be able to count occurrences by day, hour, minute, and second. And while not rocket science, it does require a little bit of thinking about. What they do here is use every row for a level in a hierarchy, and within that row, use the columns to maintain the subcomponents at that hierarchy. So for every day, you maintain a row. For every hour, you maintain a row. And for every minute, you maintain a row. And inside each of those rows, inside an hour row, the actual minutes are encoded as columns. So this is pretty convenient, because if you notice here, you'll be able to build what's basically a graph of these numbers, these occurrences over time at any granularity here by just doing a single slice operation on a particular row. So, here's the pattern. So for every event coming in, the time that that event occurred increments several different buckets. So we're firing +1s into several different places in the data model. And what you can do there is then go and ask any query about, give me the number of occurrences between any two distinct points in time. And we will do at most 2 slice operations at every level in that hierarchy. So you can see there, asking on the right-hand side for the counts between 11:59 and 13:02, we get the hour bucket for 12 o'clock to 1 o'clock, and then we just add the minutes on either end. And that's a pretty powerful way of being able to get a high-level view as to what's happening, and then be able to drill down further, and to be able to draw that on a graph with any particular time granularity and show the change over time. So the second thing was, how do you add wheres to this, right? So they were looking to filter these call detail records, these alerts, and these occurrences by a number of different fields, right? So you're looking at things like device type, model, carrier, and particular characteristics of the network. Now, there are a couple of different ways of encoding wheres, but basically what you want to do is include it in your row key, in your partition key in a CQL term. And the reason for doing that is that when you're filtering, you're unlikely to, you're filtering, you're trying to do something like select me the number of occurrences, group by time, where this thing happens. So you're unlikely to need to touch multiple different where values at once. If you are fine, there's potentially other ways of doing it. But usually it's a filtering type operation. And so here you're augmenting the row key, and you're having to augment every single combination of the row key that you've already got with each value, respective value from that filtering field. So GroupBy is a sort of similar operation. What you're doing there is you're just augmenting the column key that you have in the field, in the data model, by the actual value of that GroupBy. So then you can slice across multiple different components and be able to pull out all those values at once. Remember, each row is going to be co-located on disk on a single or small number of machines in the cluster. So to go and get back that data, you're going to only need to go to one place on disk. And that's what you're looking to do. You're looking to minimize work for every operation that you do. So the next challenge these guys set us was, okay, so we've got all of this is nice, but we've seen some anomalies. So we'd like to find out what the constituent events were. We want to find out why, of this sort of latency histogram, say, that you've just built using the techniques you outlined, why there are these outliers. Why are there twice as many dropped calls in this particular area or for this particular device type at this time? I want to understand what those call detail records were. I want to understand what subscribers they affected. So what we do there is actually use an identifier in the column key and store the event in a different column family as well. So we maintain basically a separate event store. And this works well for this customer. What you're doing here is you store the original event, some of which, some of that data is not going to be useful for grouping, some of it's not going to be useful for filtering, and it's just going to be useful for finding out more detail about the underlying causes of a particular piece of analytics. So we maintain basically this ID mapping. So it's like a sort of manual secondary index, if you like, but managed by yourselves inside the Cassandra data model. So you see now what you're getting is quite a lot of different colors in this data model. And remember, these diagrams are simplified because what you're going to need to do is for every time you do a where or a group by or maintain a drill down, you're going to need to manage all of this through CQL. So we got to a point where these guys were asking us to do, we ended up with quite a lot of color in the data model from that point of view. And this was getting pretty tricky. So at this point, the system was working nicely, but the customer wanted to change things. So the manager, they demoed it to their managers. They saw how much potential it had, and said, actually, please can we do this? Please can we filter on by these different characteristics? Actually, please can we do this other form of analytics here? And I'd like a drill down for this particular aggregate to this particular event. And then, of course, they also asked the question, very reasonably so, actually, could you just hand the system over to me so I could do that? And suddenly what you're looking at is needing to be able to offer what currently you're doing in CQL or in Thrift through to your business owners, through to managers. And in fact, the big problem really is that you can never anticipate complete requirements, and this is a big part of the challenge. So after a little bit of iteration on this, a little bit of the customer having learned some of these techniques and built this, they said, actually, is there a better way? And so from that experience, what we ended up doing was productizing some of this. So we noticed that there was much commonality in the data models that people were building and wanted to help people build something that was a level higher. So we put together a framework which we call Acunu Analytics, and it's for Cassandra users, you can think of it as doing three things. It provides you with a simple data ingest mechanism. It provides you with a way of automatically managing your data model, and it provides you SQL-like queries. So I'll talk to you a little bit more about those things. But all of this actually includes a lot of the data. It really started out as the data model that we worked with on for a number of customers. Acunu Analytics allows you to collect data from via a RESTful HTTP API. You can just fire JSON objects at it, or log lines. We have Flume integration, Storm integration, and various message queue integrations. And what it's doing is it's basically building continuous, so OLAP-style cubes continuously on ingest. So rather than wait overnight and come back in the morning for your data store to have built aggregate cubes across a range of dimensions, which is essentially what you're doing in Cassandra, but in real time, we allow you to do that using a high-level language, using concepts familiar from SQL like wheres and group bys, limits, halvings, joins, and so on, but without having to go into the detail or the depth of managing CQL. So data comes in, we use Cassandra to store raw events and aggregates, and you can issue queries out of this JSON API, which actually touch Cassandra, the aggregates in Cassandra. We also have a bunch of dashboards which allow you to basically build very easy, quick, real-time visualizations of all of this data. So very briefly, I'm just going to screw up the graphics system here to give you a bit of a demo. So I was just talking to Eric Evans over in the other room, and he said to me, I have never, ever given a demo at a conference because they almost always go wrong. So what I'm going to do here is prove Eric right and see whether we can make something happen. So what I'm just going to show you is basically how you can achieve all of those Cassandra data modeling techniques actually in about 3 minutes, hopefully, before my time runs out. So the first thing I'm going to show you is that we have So we have a UI here. So basically, Acunu maintains a set of dimensions and a set of cubes on top of a table. And that table has an endpoint which you can fire JSON events at. So I'm just going to kick off a load generator which is firing some latitude, longitude, timestamp, duration, and other data at it. So what you can see here is that we've just basically said treat timestamp as a time and just aggregated up this hierarchy, and treat latitude and longitude as a hierarchy, aggregated at these levels, and maintain these cubes for me, because basically that was what I was doing in my Cassandra data model. So when you do things like head over to here and say something like, show me the count between 5 minutes ago and now, group that by second, you get a bunch of results. And I don't think this is probably classified as big data either, because we're only doing about 40 a second, because I did it particularly slowly. But you can then, when your boss asks you to also, well, compute me the average duration of calls coming in from those call detail records, I can do that. And then you can go and add that to a dashboard that I will call demo. And then you have real-time analytics powered by Cassandra on data sets where we've deployed this, I think, up to about use cases with about 5 billion events a day. So analytics scales out linearly over Cassandra, and you can then also go and run queries like this one that I made earlier to do exactly the sort of, you see all the SQL-like concepts there, to do exactly the sort of analytics that this customer was aiming to do with Cassandra directly. So, make myself a new dashboard. So there I have a real-time geo heat map updating, aggregating cool detail records that's basically powered by Cassandra. And you didn't need to write a single line of CQL to do this. In fact, it's pretty much all just set up through the UI. So these queries are just significantly higher level than you would have to do if you were using Cassandra directly. So it gives you the power of Cassandra, but also helps you get to value more quickly. So what I'm going to do just here was just change the latitude and longitude granularity, because we have those two buckets, and now we're going to aggregate it at just a different hierarchy. So you can see, actually, I'm collecting results at just a different granularity there. So, but this isn't just a tool designed to, there's an API behind this. It's designed to help you. It's designed to help you build real-time analytics applications. And one of the things you can do is just you can very easily embed these widgets in your own sites. So, for example, there's a JavaScript library, and I can go and stick this text into a HTML file like this, and run over to here, and hopefully when I run that, I have an embedded graph collecting metrics powered by Cassandra, which you can then go and put into your own applications. So I think that's all I had to say. Thank you. And Eric, if you're in the room, you owe me a beer. Any questions? Okay. Yeah, have you got a microphone? Or I can maybe repeat back your question, or maybe you can shout. Yep. So how does this relate to Storm? Where would you use this alongside Storm? Well, we have actually a number of customers who use Storm at the front end of what we do. So Storm, for those who don't know, is a sort of a distributed stream computing setup where you just fire streams of events and do processing on it. So Storm is like a CEP system where we see Storm as a sort of upstream setup for processing data on the way into analytics. The difference with analytics is it's a backstop for your data. So the trouble with stream processing is that once you've done your processing, you need to store that somewhere. And if you haven't got anywhere to store it, you can't come back later and ask for questions on it. So Storm on its own is great for use cases where you are looking to basically do processing that spans a window of time which you can fit in memory, and then maybe raise alerts out of that, or raise sort of downstream events. But Acunu Analytics allows you to do that, but also maintain historical context. So quite a lot of our users do things like raise me an alert when the volume of trades for this particular symbol has fallen below the mean -1 standard deviation of the usual level that stock trades at for 10 o'clock to 11 o'clock on Tuesdays, this time on Tuesdays historically over the last 6 weeks. Or just show me that graph and show me another line of what happened last week. So it's like you have that historical context, and you can come in and ask asynchronous queries of it rather than just do something downstream at the time an event comes in.